Namaste everyone and welcome back to our channel. Today, we are diving into a super interesting and powerful feature of Java called the Java Reflection Application Programming Interface. Have you ever wondered how some tools can inspect or even change parts of your Java program while it's actually running? Well, that's the magic of reflection. In this beginner-friendly tutorial, we will explore what reflection is, why it is so useful, and how you can start using it in your own projects. We will cover how to get class objects, inspect their members like fields and methods, and even create objects and invoke methods dynamically. By the end of this video, you will have a solid understanding of this fundamental concept. So, grab your virtual pen and paper, and let's get started. Our journey into reflection begins with understanding the class object. Think of the class object as a blueprint or metadata for any Java type. Every object in Java has a class object that describes its structure and behavior. To use reflection, the very first step is always to obtain this class object for the type you want to inspect or manipulate. There are primarily three common ways to do this. First, if you already have an object, you can call its getClass method. Second, for any known type at compile time, you can use the .class literal, for example string.cls. And third, if you only have the class name as a string, you can use class.forName, which is very powerful for dynamic loading. Let us look at a quick example to see these in action. Once we have our class object, the real fun begins, inspecting its members. The Java Reflection Application Programming Interface allows us to look inside a class and discover its fields, methods, and constructors at runtime. You can retrieve arrays of field objects, method objects, and constructor objects from the class object. For example, getDeclaredFields will give you all fields declared by that class, getDeclaredMethods will give you all methods, and getDeclaredConstructors will provide all constructors. These methods return arrays of java.lang.reflect.field, java.lang.reflect.method, and java.lang.reflect.constructor respectively. With these objects, you can then delve deeper, getting information like their names, return types, parameters, and even modifiers such as public or private. This capability to programmatically examine the structure of a class is incredibly powerful, enabling many advanced programming techniques. Now, let us put these concepts into a practical scenario. One of the most common and powerful uses of reflection is to dynamically create objects and invoke methods without knowing their exact types or names until runtime. Imagine you are building a plugin system where you load classes based on configuration files. With reflection, you can read a class name from a file, load that class using class.forName, then find a suitable constructor using getConstructor, create an instance using newInstance, and finally, find and call a specific method using getMethod and invoke. This example demonstrates how we can create a person object and call its sayHello method entirely through reflection, showing the flexibility it offers in building highly configurable and extensible applications. This truly unlocks a new level of dynamic programming in Java. While the Java Reflection Application Programming Interface is incredibly powerful, it comes with its own set of challenges and common pitfalls that beginners often encounter. One frequent mistake is overusing setAccessible, true to bypass access restrictions on private members. While sometimes necessary, doing this too often can break encapsulation and lead to less maintainable code. Another important consideration is performance. Reflection operations are generally much slower than direct method calls or field access because of the overhead involved in looking up class information and method handles at runtime. Security can also be an issue, as reflection allows you to circumvent Java's tight safety and access control mechanisms. Therefore, it is crucial to use reflection judiciously and only when standard Java features cannot achieve the desired outcome. Always remember to handle exceptions properly, as many reflection methods can throw checked exceptions. Alright, we have covered a lot in just 5 minutes. Let us quickly recap what we have learned about the Java Reflection Application Programming Interface. First, we understood that reflection allows your Java program to inspect and manipulate its own structure and behavior at runtime. Second, the class object is your gateway to reflection, obtainable through getClass.classLiteral or class.forName. Third, we saw how to inspect class members like fields, methods, and constructors using getDeclaredFields, getDeclaredMethods, and getDeclared constructors. Fourth, we demonstrated how to dynamically create objects and invoke methods, which is incredibly useful for frameworks and plugin architectures. Finally, we discussed important considerations like performance, security, and the need for careful usage. Reflection is a powerful tool, but remember, with great power comes great responsibility. Keep practicing and experimenting with these concepts. If you found this tutorial helpful, please give it a thumbs up, share it with your friends, and do not forget to subscribe for more Java programming insights. Happy coding!